still doing polynomial functions, but we're going to do operations with them today a little bit more. If I gave you the function f of x is equal to negative x squared plus 5x minus 11, I'm asking you to evaluate for f of negative 4. Now we did this problem earlier in the week, but we're going to end up taking it a step farther today. So if we're to evaluate for f, or it might have been Algebra 2 that did that. Y'all are kind of doing the same stuff right now, and I get confused on who's done what. But anyway, you know how to do that. F of negative 4, we're just going to plug negative 4 in for all the x's and evaluate. So f of negative 4 would be, this x squared has a negative in front of it. You can't lose that. Negative 4 squared plus 5 times negative 4 minus 11. Just plug the negative 4 in all the x spots. Negative 4 squared is 16, but then it's got a negative out in front, so it stays negative 16. 5 times negative 4 is negative 20, and then minus 11. So f of negative 4 would equal negative 36 minus 11, which is what? Negative 47. That'd be it. Just plugging it in. Yep.
That's good.
Alright, here we've got, I need to go back, Summer?
Oh no, I
Thought you were growling at me.
Thank you.
Here we got f of x is 3x squared plus 8x minus 6. G of x, giving you another function now, g of x is negative 4x squared plus 4x minus 8. Okay, what we're going to do, two different problems here. We're going to find, first off, we're going to find f plus g of x. Then we're going to find f minus g of x. Okay, so this is exactly what we did yesterday now. It's just a fancy way of writing it. On f plus g of x, that means we're going to take the f function, 3x squared plus 8x minus 6, and we're going to add that to the g function. Negative 4x squared plus 4x minus 8. So that's exactly yesterday's work. Like term hunting, 3x squared and negative 4x squared. It's negative 1x squared. 8x plus 4x is 12x. And then negative 6 plus negative 8 is negative 14.
So we did this in college algebra. You should have made it so much harder.
Yeah, like I didn't do
So you should just do college algebra.
No, because I like it here.
Thanks, Austin. Makes my heart happy. Alright, now we're going to do the same thing, but this problem is subtraction. Okay, so put them in the order it tells you, because subtraction order does matter. So we're going to take 3x squared plus 8x minus 6 minus negative 4x squared plus 4x minus 8. So same thing now, just like yesterday, you're just subtracting your like terms. So 3x squared, be careful with your signs, minus negative 4x squared. 7x squared. Bump that up so we can all see it. 8x minus 4x, that's an easy one. Good job. And then negative 6 minus negative 8. Is 2. That would be f minus g of x. Hot dog. Okay, everybody good? Keep adding some stuff on. Alright, I got two new functions this time. They're actually shorter functions. F of x is 18x squared minus 24x. And g of x is just 3x. Alright, we'll find four things this time. We're going to find f plus g of x again. Then we're going to find f plus g of negative 1. Then we're going to do f minus g of x and f minus g of negative 1.
Negative 1 would be the x, right?
Yep, yep.
Cool.
Alright, so let's do this f plus g of x first. My marker just disappeared. Froze. See it, but it's not moving. There you go. F plus g of x, so I've got 18x squared minus 24x plus 3x. So the only like terms you have are the negative 24x and the 3x, right? So that would be 18x squared minus 21x. So that would be our answer to f plus g of x. Alright, now here's your options, and this is the way I would do this. On this problem over here to the right, f plus g of negative 1, we just found f plus g.
Plug negative 1 into x on that one.
Good, so I'm going to take that answer that I just got, and that's where I'm going to plug that negative 1 in. Austin has got it, so it's going to be 18 times negative 1 squared minus 21 times negative 1. So that's 1 times 18 plus 21, which is 39. Okay, now, go ahead and ask your question, because then I'm going to tell you another way you could have done it. Okay, hold on, these girls are confused.
Why did you use that problem instead of the original?
Because that was what f plus g was. Now, I didn't have to do that. That's the other way I'm going to show you in a second.
So you did, okay, yeah, I see what you did.
Austin.
On the 18 negative 1 squared,
Uh-huh.
why didn't you square the 18? Once it was negative 18.
The squared is only on the negative 1.
Okay, so it just goes away.
Yep. Because negative 1 squared is 1, so it didn't change any. Alright, other way you could have done it, and this might have been where Bailey was kind of expecting me to do a little bit. I could have put negative 1 into the f function and got an answer. I could have put negative 1 into the g function and got an answer. And then I could have added those two answers. So that's the other way you could have done that. Do you know what I'm talking about on that? What that would have looked like.
Which the way you did it was easier.
Yeah, it was shorter. And if I plug negative 1 into the first one, it would be 18 times negative 1 squared minus 24 times negative 1. So that would be 18 plus 24, which is 42. Is that right? Okay, then on the g one, 3 times negative 1 would be negative 3, so 42 plus negative 3 would have been 39. So you could have done that either way on that. So,
Make sure you read this through. I'll probably connect.
must be Stuart, I haven't copied anything. Thank you, sweetie. Should have just took them and started handing out work. I don't know what we're doing. Here we go. Stuart will be over there searching for her work all day. Alright, f minus g. So down here on the f minus g, can y'all see that? Got 18x squared minus 24x minus 3x, because this one told me to subtract them. So only like terms now, I've got negative 24x minus 3x. So that'd be negative 27x. So now on this problem, again, I could do it the way I did on the dry erase board over there. I could plug negative 1 into the f function, negative 1 into the g function, and subtract. It's shorter, in my opinion, since this is f minus g. Just plug the negative 1 in there. So I'm going to have 18 times negative 1 squared minus 27 times negative 1. So negative 1 squared is 1 times 18. Negative 27 times negative 1 is positive 27. Is that 45? It's funny, we got a smaller answer when we added than we did when we subtracted.
That's weird.
That's not what the answer's supposed to be.
What did we do wrong?
Nothing.
It's all my fault.
18x squared minus 27x. We got that part right. Negative 1 squared.
1.
Oh, okay. The book problem said to find f minus g of 1. So we did negative 1 still. So if we're right. I wrote the problem wrong, different than the book wrote it. Alright, ready to move on? Easy schmeezy still? Okay, this time f of x is x minus 4. G of x is just x squared. Alright, some new symbols for some of us now. We're going to find f of g
I know this.
of 3. Now, every year someone will say, what is fog? That's not an O in there, that's a little bitty circle. F of G of 3. Another way of writing that you might have seen, some people do it like that. Okay, those mean the same thing. F of G of 3. Okay, what you do on something like this is pretty simple. You always start with the inside function first. Work your way inside out. So I'm going to go to the G function, which is right here, and I'm going to plug in what they told me to. So in the G function, I'm going to plug a 3 in. So G of 3 is going to be 3 squared, which is 9. What I got there now, that got me the G function, so I've got to now plug that into the F function. So the F function says x minus 4, so I put my 9 in there. So my final answer for F of G of 3 is 5.
That's it.
That's it. You go into the inside one first. So G was written on the middle, so I plugged into it. Whatever you get for that answer, you plug it into the function on the outside.
Is the O on paper going to look like? Is it going to be obvious?
Yeah, it's real small in there.
Just read it like fog.
Yeah, it's going to be like fog. Like a fog. And then a fog
something
one.
else though.
I've never. I
I
don't know.
don't
Opposition.
even know.
What you call it? Opposition
I don't
functions.
know, maybe, we all call it like that fog, you know, like when it says like fog, and she's like, well, and I was like,
I would just rest it down.
Alright, f of x is 3x plus 6. Sure, you already fell into this relative combination, please. G of x is x cubed. No, he didn't. He asked first. Maybe I had some more comments for him. F of G of 2. Then we're going to do something a little bit different after that one. G of F of X. Alright, so let's do that one on the left first. F of G of 2. That's like the one we just did. Where am I going to plug the 2?
X.
X cubed.
Good, over here in the x cubed one. So it's going to be
That's
2
right.
cubed. I knew that's what you meant. 2 cubed, which is 8. So now where am I going to plug that 8?
X on 3.
And 3x.
Good job. 3 times 8 plus 6. So that's 24 plus 6.
30.
Good job. The Austins have got it. Alright, everybody good on that one? Now over here on the one on the right, it's got an X in there. That's where people sometimes get confused, but it's just as easy because you're just not going to get a number answer. They're already in terms of X. So they're just asking me to keep it in terms of X. So I don't have to plug anything in for it at all. I go to the inside function. This time it's the F one, so I'm going to take the F one first. 3x plus 6. Now I'm putting that in place of the X on the G one. So I do all that to the 3rd power.
That's it.
Distribute.
Now you wouldn't actually distribute. If we wanted to simplify it, we'd have to write that out 3 times and multiply it. But we're just going to leave it like that.
That'd be an answer choice.
Yep. So we took the inside one, y'all good? Took the inside one and put it in for the variable in the outside one.
But my brain doesn't get this.
We're gonna do another one, but f of x is on the middle.
so that's
So-
the same way we did the other one?
Yeah. We just, instead of having a number, we had the whole expression. Because it told us to leave it in terms of x.
Oh, okay.
We're gonna look at another one, don't panic.
And then, okay, so but on the other one, since we have a number for the first one, we can put it into,
In for the x, yes. So that's the difference on what they're asking for. You got a number, you're gonna get a number. You got a variable, your answer's still gonna have a variable. Alright, let's do another one of those with the variables, since that's a little bit trickier. I got f of x equals 3x plus 6. Well, that's the same one. Hold on, I got a
I was
different
about to
one.
say it's like,
14
I didn't even
squared.
think about it. No, we're all saying, I was like,
4x minus 1. And g of x is x squared plus 5.
Is it fog or goof?
Well, we're going to do fog. Who said fog or goof? F of g of x.
G's in the middle.
Alright, so g's in the middle, so here's my g. Write that. Now that goes in the place of the x on the F1. So that gets good, Austin, that gets multiplied by 4. See, this whole thing went in for the x on that one, and then it gets subtracted 1 from it.
Distribute.
Okay.
Okay, and we can simplify this one pretty easy.
I kind of got it when we were in college algebra, but she tried to explain it like.
Okay, so since it's like still an x, nothing changes.
Right. You just plug it into the other one.
Wait.
4x squared plus
You
19.
just pointed it
So we had to take the g.
Which one would be
It's,
an answer?
it's like substitution. It's like substitution. You take the g and substitute it in the F1. So see what was just an x there? The whole g function went there. So let's flip that one. Let's do goof, as Austin would say.
Yeah.
Goof sounds fun. Alright, so we're going to write the F1 first here on this one. So we're going to write 4x minus 1. Okay? Now, that 4x minus 1 has to go in the x spot of the g one, so that whole thing needs to be squared,
Plus.
and then add 5 to it. Okay? Now, I'm going to go ahead, since it's just squared, and simplify that. Do you realize that's a FOIL problem to simplify it? So we got to write 4x minus 1 twice. That's what the squared means.
I hate doing that.
I never did understand for it.
Alright, so first one in each parentheses, 4x times 4x, 16x squared. Outer, 4x times negative 1. Inner, negative 1 times 4x. And the last, negative 1 times negative 1. Like terms in the middle, 16x squared minus 8x plus 1. Don't forget that plus 5 that was on the end. I need to bring that down and clean that up.
Plus 6.
Yep. I can't even keep up with y'all. Y'all are doing better today.
Okay, I talked to myself. Minus 8x plus 6.
Good deal.
Yes.
Alright, last thing that we have with this part of this lesson is domain and range when we graph them.
That's what's, yeah.
Easiest thing, and you can graph them, you know, I've shown y'all in Algebra 2, graphing by hand. We can graph by hand, we can graph on a graphing calculator. Doesn't really matter. Oh, sorry, I still saw some people writing and I hit next. There you go. You got it. Alright, you good up there, Phyllis? Alright, so let me get a piece of graph paper here. Alright, we've got f of x equals negative 2x squared. Directions say to graph and give the domain and the range. Graph and give the domain and the range. Now, you can graph this.
What's he doing?
You gotta play beauty shop over there. You can graph this by hand or on the graphing calculator. It doesn't matter. Either one to me is fine. If you want to graph it on the graphing calculator, remember that top row of buttons is your graphing buttons. So you're going to hit y equals. F of x is the same as y equals. And then just type that in. The x button is right below mode. It's that one with the x, the t, and the theta on it. Alright. I'm going to graph it by hand real quick. This is a parabola. I know that because it's squared. I know on this that my vertex is going to be at 0, 0. Okay? Reason I know that, and this is not stuff we've covered yet this year, but it's review from Algebra 1 and Algebra 2. To find the vertex of a parabola in standard form, your x is negative b over 2a, and this doesn't have a b in it. So my b is 0. 0 divided by anything is 0. So the x, the axis of symmetry, is 0. When you plug that back in, negative 2 times 0 squared, y is 0. So my origin will be at 0, 0.
What did you?
Negative b over 2a is how you start finding the vertex when it's in standard form. Alright, now I'm just going to pick another point on one side of that. So I'm going to plug a 1 in. See what my y would be if x is 1. Negative 2 times 1 squared. 1 squared is 1. 1 times negative 2 is negative 2. Okay, so I'll go right 1 and down 2. Now, I don't have to do any more math from that, because this vertex in a parabola is your axis of symmetry. So if this point is 1 away from the axis of symmetry, I got to have a point in the same spot on the other side, don't I? That's what axis of symmetry means. It's like it's an image, you can fold it. So if I'm 1 away here, I got to be 1 away on the other side. So there's what that parabola would look like. Is that what you got on your calculator? I should have known it was going to open down because the negative 2, the a was negative, so that told me that. All right. So that's funny. So we got our parabola. Now the domain. On any parabola, domain is your x's. In case you forget, that's what it does, right to left. Okay, left to right. On any parabola that's upright or down, on a vertical parabola, it's going to keep going to the left forever, and it's going to keep going to the right forever. So our domain on that is going to be all real numbers, is how I sometimes say it. Another way to say it would be from negative infinity to infinity. Okay, it's going to keep reaching right and left forever. Now this thing, range, is your y's, in case you forgot, up and down. It's not going to go up and down forever. Its highest point is going to be 0 on the y, right? But its lowest point, it is going to go down forever. So its lowest point is going to be negative infinity and then 0. Look what I put on 0. Remember the difference between the bracket and the parentheses? It touches 0. So 0 got a bracket. You can't touch infinity. It gets a parentheses. Can't touch this. No. I made your brother do that MC hammer when we did that in his class.
You did what?
I made him do the hammer dance when we did that in his class. It was not very good, but it was quite comical. Bless you.
What a killer.
All right, one more. One more. We ready?
Yeah.
Yo. One more graph. One more graph. All right, this one you've got f of x is x cubed minus 2. All right, not a parabola on this one. Okay, just a little bit of a review. That highest power on it's a 3, which is an odd number, which means the ends are going to go in opposite directions. If your highest power is odd, the ends go opposite. If it's even, they go towards each other. So this is like a lightning bolt type of graph, a snake type of graph. The ends are going to go opposite of each other. So some of you have already got it on your calculator. Keep that up there so you can check mine in a second. I'm just going to make a quick input-output table. Do a couple of small negatives. I always like 0, a couple of small positives, and see if I can get a picture of this. I'll do this real quick here. Negative 2 cubed is negative 8, minus 2 is negative 10. Negative 1 cubed is negative 1, minus 2 is negative 3. 0 minus 2 is 0. 1 cubed minus 2 is negative 1. 2 cubed minus 2 is 6. Check your table, those of y'all that already plugged it in your calculator.
You say 0 minus 2 is 0?
Oh, did I? Uh-oh, thank you. 0, that should be a negative 2. Thank you for checking that. 0 minus 2 is negative 2. Did I miss another one? Do what?
No.
All the rest of them were good? Yeah. All right. Negative 2, negative 10. That's going to be way down off the bottom of my paper, so I'm not going to go looking for it. Negative 1, negative 3, 0, negative 2, 1, negative 1, and then 2, 6, be up there off the top.
It looks like a little snake.
So this is going to be coming from down forever, then it's going to curve through there, and it's going to reach way on up there and try to find that point. Alright, now on your calculator, mine, I've got way more spread out than you do. Your screen on your calculator is counting by tens, and it's squishing that all in. So it's not going to have the same spread out effect as mine, but other than that, Shelby thinks it looks alright. Did y'all up here think it looks alright? Good.
Looks good. Looks good.
Okay, domain and range. This is easy on domain and range. Is it ever going to quit reaching a little bit to the left and a little bit to the right?
No.
No, so it's domain and its range. It's going to be negative infinity. There's domain. It's going to be negative infinity to infinity. With parentheses, good. What about range?
Negative infinity.
What? No, I meant Austin, I'm sorry.
That's a congrats on the win.
I don't mean to tell you. Go ahead, Austin.
Negative infinity. Positive infinity.
Very good. It goes down forever and up forever. Very good. Good. Mr. Jackson.
So whenever you're doing like the negative infinity stack, is it always going to be
Yes, put the smaller one.
Yeah, because I tried to put 0 first one time around.
Put the smaller thing on the left. What Kelsey was just talking about, always put in your parentheses with domain and range, smaller goes on the left. Just like on a number line. Smaller's on the left, bigger's on the right. So negative infinity will go on the left.
So it's smaller than infinity.
That's right. That's right. Alright, everybody alright?
Yes, ma'am.
Okay, that's about it.
That's a wrap.
That's a wrap. Which one describes the true relationship between those functions? Okay, what it's saying there when it says they're equal, that means that's where they intersect. So those would be equal in two spots. So that one would be right. And there's more than one, that's not right. F is...
So like where they intersect, that's two.
Uh-huh. Is that what the right answer was before I keep going on?
No, you would not. Yeah. That's the way
Well, I can help.
That's easy. Who's Teddy Bear?
Oh,